very good afternoon to everybody over here. So I believe that it has been quite a long day, a number of camp topics and so on going on earlier in the morning. And we've also heard from each other's spaces what is it all about and all that. I hope you have enjoyed the program thus far. So today we are going to be doing one hands-on workshop after all the talking and all the eating and all the meeting. So today we will be covering fast and furious prototyping. So before I begin, my name is Joo Khai. I'm actually from OneMaker Group. So since about September last year, we were running the prototyping lab at National Design Center, which is the one at level 1, where you were hacking your own t-shirts earlier. So at the lab, I'm actually the lead for electronics and digital fabrication. I've seen all different kinds of prototyping happen. I've seen different kinds of mistakes and also a fair share of accidents. Things happen sometimes. So there's a lot of concerns when it comes to prototyping. It's about safety, it's about efficiency, and many other factors into consideration. But today we'll be pushing the boundaries of things. And even before that, together with me today is Wilfred as well as Sullivan. So Sullivan is working part-time for the Sustainable Living Lab, which is a social enterprise dedicated to urban making. And Wilfred just joined us about a couple of months back. In fact, less than 2 months, right? Less than 2 months. So he was hoping to actually gain some experience before he gets into an electrical engineering course in university. So everyone here is a maker. So don't be afraid to make mistakes. Don't be afraid to ask. And of course, this session is not for us to do a one-way lecture, but essentially for us to learn from each other. So what we have is only 5 to 10% of the collective brilliance of all of us. So welcome to the Fast and Furious Prototyping session. So when we think of making, and if we happen to read Make magazine, social media, and a number of the other news and mainstream media and things going around on the maker movement, some things stand out and are very iconic. For example, Arduino projects here, over there, Bay Area Maker Fair, Shenzhen Maker Fair, whatever it is, Arduino, and more Arduino. Sure, that's good, because Arduino allows us to quickly prototype an electronic solution, put together a solution, and have some kind of automation or interactivity. Soldering, the soldering iron, the 3D printer, the laser cutter, and all these fantastic digital fabrication tools that were not available a decade back, but have become so relevant, have changed the way we do prototyping. So in the past, prototyping, as I personally learned in high school or secondary school over here, was about learning to use saws, files, and other basic hand tools, or even an acrylic bender, and work with acrylic, sheet aluminum, as well as wood. Saw something, drill something, file something. But that was a decade ago. So a decade ago, offices were full of filing cabinets, files after files after files. But computer-aided design software has changed the entire workflow that we tend to be fascinated about 3D printers, CNC cutters, laser engravers, laser cutters, vinyl cutters, and other kinds of digital fabrication tools. These are very efficient, these are very good, but sometimes it's also good to take a look at what else. What else is there? So, should I 3D print everything? Is a laser cutter an optimal solution for everything? Some of us may know, if we are working with laser cutters, that cutting polycarbonate isn't a good idea, because the chlorine gas that's produced is going to mess up the wires, and all you have is, as though your laser cutter wires have been bitten by rats. It's going to crack out, it's going to short. So each technology, although it has its very strong advantages, also has its limitations. So we'll be exploring the less known or not so familiar options, but things that we have been trying out, things that we have been doing and are proving to be useful. So today, we'll be looking at different tools, techniques, and methodologies to actually build things up and take material down. So very often, for those who have come in, just grab a chair and join us at the front. Yeah. So feel free to put down your bag as well. So in terms of making, most of the time we are taking a look at a lot of machines and techniques to build something up. From just a circuit board called Arduino Uno to a full robot. From 3D printer filament, a spool of plastic, to a printed object, maybe a Yoda, maybe a Minion, maybe a Baymax, but there's no purpose in it unless you do something useful. Many times we are fascinated by how this technology can help us to build things up, but very often, oh, it doesn't fit well, I think I need to trim off this portion, how do I do it best? How do I cut a square hole? I messed up in the computer-aided design drawing. Am I going back to the drawing and to the 3D printer for another 8 to 16 hours? Sometimes there are quick hacks, but good hacks around that. So we'll be looking at the build-up process and also the process of taking down material and all different kinds of hand tools and other nifty tools and methodologies are available at our disposal. So very often in a makerspace, what we do can be distilled down to two things. So at OMG or OneMaker Group, we run a number of hackathons, we curate technology talks, so we have one technology talk every week. We have Tinkering Thursdays where we up the value of experimentation and innovation. People sometimes think of tinkering as you're not serious, you're a hobbyist, that kind of stuff. But we have sharing sessions on innovation as well as experimentation where people come together to tinker and to discover new things for themselves. So what we do as a makerspace, although it's a myriad of activities, and of course like most spaces, we also have members or users coming to use the tools and the resources. We are of the opinion that a makerspace is not just a place with tools. We are not just a place with books. We are a community. We are a conducive environment. So first and foremost, a conducive environment for people to innovate, having the necessary resources. And the second thing, if we teach classes, when we run hackathons, when we curate technology talks, when we create opportunities for people to get together, what are we really doing? We are communicating. In what sense? Human to human. It could be a class, it could be a talk, it could be a networking dinner. Human to computer, computer-aided design. So very often, we encounter budding entrepreneurs or makers. I have a box over here. So this is my box of electronics, and I'm going to put in an Arduino, but I have a sensor inside and it cannot be exposed to rain. So I need a shield, a cover that has a flange with two holes that are around 3 mm and with a kind of shield that protects it from the rain but allows me to start this stuff. Okay, so how does it look like? But nowadays, today's CAD software or computer-aided design software allow us to very quickly get our ideas into the computer. So a lot of what we do is facilitating the process of human to computer communication, human to human communication, and also lately with IoT, Internet of Things, machine to machine communication. So if this part of the room were to have a problem with the air conditioning, you probably know. So machine to machine communication as well. So the two things that we do primarily as a makerspace in Singapore are facilitating communication and also at the same time having that conducive environment. So since we have started in September 2014 until now, we realized that a lot of the hand tools and other kinds of methodologies which we also practice internally revolve around three use cases of prototyping or making. The first will be to communicate an idea. So there are tools which we'll get to use later like 3D printing pen. So some people think that it's a toy, it's not a toy. It's very, very useful for ideation. Sometimes you could be with a person who can help you further an idea, help you to better express the idea, or show you which process is best to actually make it. But you don't know how to sketch well. So that becomes a handicap, but no longer with the 3D printing pen. So sometimes these tools, which you will encounter later, are being used for ideation, communication, and demonstration. We also have tools and methodologies for semi-permanent fixes. So for example, you are actually building a robot and you have a distance sensor. So before the robot collides into the wall, it will stop based on your software. Of course, it has no bugs. So sometimes you need to aim a sensor, you need to position a sensor in a way that it can pick up the physical phenomena. So you may wish to 3D print a part where you put the sensor in, but you've just wasted 8 hours. Oops, the angle is wrong. Is there a faster way? Yes, you do it later on. So we have things like polymorph, we have things like Subaru, which we'll introduce, and also permanent methods. So some of the things that you will encounter later can also be used for permanent fixtures and mounting. So these are the broad categories of making and prototyping which we have noticed taking place with these tools and technologies which we are using. So we also see the activities that happen in our space and also in the individual companies that form the consortium. So these activities are actually building or creating. So a number of people actually use tools and resources to build and to create new things. Others do a different kind of making. That kind of making is actually hacking or repurposing. So, for example, right now, as I'm speaking, the people in the Intel IoT workshop may get a chance, depending on how familiar they are with Arduino and the Internet of Things, to hack in such a manner. So this wooden item over here was originally an IKEA stool. So this is the top where you sit on, and these are actually legs. So it was reconfigured and screwed in place to form a table, a side table, to hold flyers. But when you distribute flyers and brochures actually run out. So when they run out, you've got to send a secretary keep checking and checking and checking. It's something that can be automated, and the Internet of Things or Arduino would actually add a lot of value. So this is hacking or repurposing. Creating and building, we are all familiar with it. From raw material, from nothing to something. But there is also another kind of making, which very often we do not take a look at, that is repairing. So in many parts of the world, especially in urban zones and urban cities, there's a throwaway culture. The phone doesn't work, screw it, okay, blame somebody else. Throw the phone away, put it away. But we also see that in other cultures and also in some zones, there's a culture of repair. And when you repair something, you better understand how it functions, you appreciate it, and you could even improve it. So very often when something's value has diminished, because the volume button is a bit cracked, it doesn't work, we lack the technical skills to actually diagnose, which can also come in very useful later on. So imagine having that piece of equipment, for example a pair of earphones, whereby the cable is frayed or broken because you just accidentally pulled it, being restored in a couple of minutes because you know how to use a soldering iron, you have access to it, and you don't have to go to the store the next day to buy one. So these are the three kinds of making activities that we also see in our space. So the methods and technologies which we will be introducing to you today or getting you familiar with are good for all three kinds of making. So first and foremost, how many of you have actually heard of Subaru? Okay, and as for polymorph, okay, so it seems that there's a few hands that go up for these items over here. So perhaps what we will do is to better understand what are your challenges when doing prototyping. So before I go into the go through a brief run through of the individual items and methods over here, perhaps we could go one round. So we will just do a short one introducing who we are, what do we make the most, and what are the typical challenges that you face as a maker. So starting from you.
Okay, my name is Andy. I'm from Snow Poly. So I'm a maker coach in Snow Poly. So my job every day is to advise students to make stuff, to advisory. So over time, 3D printer is the most things.
Okay, so most commonly used is 3D printer, and what's the largest or most common challenge that you face?
Because I'm using FDM, so I see FDM is leading to a big problem. And sometimes the print out is not very detailed and it's a more
Sure.
My name is Louis, I'm from Poly also, so I'm actually Poly. So both of us actually work and basically on the same thing, day-to-day basis. As for challenges wise, I think for him it's really great because it's more of an expert. As for me, I think the challenge is how are we gonna encourage students to do that? Mine is a bit more focused in the sense that hoping that the students come and make things. I think they just like to give us once in their lifetime that they are on this section. When they are not studying, after that they come my work, time is not on their side.
So your challenge is actually helping students to make the most out of their time in school. Sure. How about yourself?
Just for nationality application.
Sure. How about yourself?
Hi, my name is Dan. I'm originally from California, but now I'm living in Shanghai. Makerspace Thailand. Sheena used to most of the as far as talking, let's just know what the results are coming out nowadays. There's so many different types of genetics. So it's not knowing if it's giving off lots of gas or not. So
program that the participant gets bring back the materials and like me keep on continuing.
So your challenge is for something that they will realize the emotional value attached with the making and continue to innovate upon it when they leave the space.
It's something that cheap enough to give this way doesn't require complicated.
Sure, we'll do that today. Yeah. How about you?
My name is Ki Chong and I do 3D printing in Cambodia. And I mostly do the business side, so I don't make my actually, I'm not really hands-on, not technical. And I'm here to get just kind of get a crash course on it. So then hopefully we can have other people who are technical come into our space and start making as well.
I'll also introduce something amazing that happened regarding the business angle when we move on to the materials. How about yourself?
My name is Ben. I'm building some makers. It's in Indonesia. I guess I think some of my problems that I have is finding materials. Something breaks or if I want to make something, going out and finding materials can be difficult, finding the right tools, and also having a lack of tools. Sometimes it's difficult for me to find the proper tooling.
Sure. How about yourself?
Hi, I'm Reza. I'm from school in Jakarta. It's actually a little bit of Jakarta. But basically not really straight into the detailed design. Basically it's science and see what it's that feel I do help friends and we have also designed tech lab so I collaborate with them so layout sourcing out materials most of it is about wood and then actually we have working on that and I also have my own project on what I'm saying plastics my challenge with that is how to make it easier mastery and more mastery and how to prototype.
Okay, we are going to be covering that today as well. How about yourself?
Hi, my name is Kui. I'm from Joo Khai, Thailand. Right now we are running in creative space. It's Makerspace Summit. You see that most of you is a mass, but the maker is not limited just a land work. So basically we from Joo Khai, we run this business for 20 years already, and right now we want to expand more to have the opportunity because middle class for new generation is more important. So right now we're trying to build up a new great people in our ecosystem.
Yes, we'll be covering the material of jewelry as well.
Yeah.
How about yourself?
So my name is Paul. I'm from Chiang Mai. I run the Chiang Mai Makerspace. Actually, my background is electrical engineering, but right now I'm a business guy to provide a space for the student on editing.
Sure. So I've seen a number of challenges that have come from, like for example, technical difficulties with the 3D printer as well as the laser engraver, thinking about how to inspire students or young minds to make the most out of their time in school and in an educational institution, something that will enrich the maker experience that they can take home and continue to innovate upon, sourcing for materials and ensuring that making is inclusive to different groups of people, especially women as well. So all these points have been noted and you're in the right place. So first of all, for Sugru. So some of you may have heard of Sugru and some of you may have not heard of Sugru. So I'll just give a brief introduction. So Sugru is this material that's available in small packets. So later on we'll be playing with it. It comes in different kinds of colors and you can do a lot of repairs, permanent fixtures as well as temporary fixtures with it. So it is a bit like clay, it's a bit like silicone putty. So you can actually use it to protect an item against impact. So for example, in some of the spaces that I have seen them use Sugru in a meaningful manner. So one small pack of Sugru, in some countries because of the import tax and all of that stuff, it can cost as much as US $6 to $8. So you may be thinking, well, it's kind of expensive for something that's smaller than a packet of chili sauce. But that small amount, if you put it along the edges of your vernier calipers, and you shock resistant or shock proof an item, then it makes a lot of sense. So these are the use cases which people have explored and are continuing to develop. So it is also a very sticky kind of material. So it can stick to a lot of common materials like woods, plastics, metals, so on and so forth. So there's also a lot of online discussion. So if you're not really sure whether Sugru will stick to your target material, a simple Google search will probably do it. So it is also a material that's strong. So people have been using it for different kinds of fixes. The most common being MacBook, as well as laptop charger adapters with a frame top, and also car antennas, as well as GPS antennas on taxis. So these are some of the more common use cases. It is also a flexible material, so once it's set, after you do the molding with your hands, you can use it for wires as well as things that need to flex a bit. So we'll be playing around with it and also discovering some use cases. You also get a chance to make something meaningful, something that's usable out of rubbish later on. So as for polymorph or polycaprolactone, so polycaprolactone is actually the scientific name of this material. It's a chemical name. So it's basically plastic pellets, but it's not a plastic that melts at a very high temperature. So with warm water to hot water, something about 60 to 70 degrees Celsius, polymorph will start to soften. So it's safe enough, even when it's in a soft state, for you to use your hands and mold and press it into shape. So not everyone wants to take the option of using computer-aided design software. Some people prefer organic shapes, and they are better with their hands, with craft knives, and so on. So we have seen a number of brooches because this material can be sanded, drilled, painted, sprayed on, carved, so on and so forth. So we have seen people use glitter paint, glow-in-the-dark paint, and different kinds of paints to create brooches, to create jewelry parts, and even for those who are actually using wearable electronics. So there's all kinds of wearable electronics right now from Samsung and from all different kinds of companies, Pebble and all that. So we have seen a number of Pebble accessories, custom Pebble accessories that wouldn't fit well, but they use polymorph to do a permanent fix for it. So they put mounting using polymorph because it's easy to work with. With a knife, with a spreader or a spatula, and a bit of heat, and you will get it done. So we are seeing it in use in different kinds of use cases. Some of them even very practical. So when the nut starts turning, they use it as a restraint so the nut won't work itself loose and the robot falls apart. So the 3D printing pen or 3D pen. So how many of you have actually encountered this before? 3D pen. One person, two persons? Okay. So it seems that in the region, the 3D printing pen is something that's not very common yet. So I would encourage you to try it later. So some people locally have given this negative remark that the 3D printing pen is actually more of a toy. Because you put in 3D printing filament on one end of the 3D printing pen and you doodle in the air and you create some noodles. You doodle noodles. No, you don't doodle noodles. You can easily use it to create some object to better demonstrate an idea. So I want a case that looks like this. I want something so my cat can go in here and take the food, but that pest will be found by the sensor and all that. So a lot of ideas can actually be illustrated in 3 dimensions, not just on a piece of paper, but in real form. And you can scale it up, you can scale it down, and so on. So also with 3D printing, one thing we definitely know if you have used 3D printers before, when there's a spool of filament that's too short to be used for the next print, what happens to it? We store it, it starts getting spider webs, or it goes into the rubbish bin. So this is wastage. How can we reduce this wastage and put that short amount of filament to good use? A 3D printing pen is more expensive. There's a number of online stores and places that actually sell it. And with a 3D printing pen, that small amount of filament that's left over can be a lot more in helping people in your space and even yourself and people who work with you to communicate ideas. So we'll be trying it later on as well. Rotary tool. How many of you are using some kind of Proxen, Bosch rotary tool or Dremel? Okay, so it seems that the same few people are using polymorph, Sugru, 3D printers, laser cutters, rotary tools and all that, but not to worry, everyone will get a chance today to make something real and useful. So rotary tools have a lot of possibilities. And I've also seen people, even from Colombia, I actually got a thank you call over Chinese New Year this year from a person in a Colombia makerspace who thanked me over the New Year period, because they came to an event like this 1 year back. It's called Maker's Block. It actually happened at Suntec, and he got the idea of how useful a rotary tool is. But because they were in a portion of the city whereby it's quite poor and they can't really afford full Dremel sets for their space, so what they did is to use old RC toys, and they would rip out the motor. And because they have access to metal working equipment, a lot of people are actually using lathes, they are using mills and all that. They created collets and jugs, and they have a simple rotary tool in multiple arrangement. Buy the Dremel bits, buy the Proxen bits, put it on, and they suddenly can do a lot of stuff, like square holes, cutting, drilling, and all that. There are also a number of guides and shortcuts, as well as helping hands and tools and accessories, which you'll get to try later on as well. So a rotary tool is good for a lot of operations. Today we also been trying out the table saw arrangement or the circular saw arrangement, and attachments that help you to do accurate 45 and 90-degree cuts for setting operations. We'll also be doing this thing called plastic welding. So this thing went viral recently on Make magazine as well as a number of online websites. When it comes to 3D printed parts, we know that 3D printed parts tend to fail along the layer lines. When it breaks, it's usually along the layer lines. So when it's going to be 90 degrees like this and it's going to be very thin on the vertical section, it's likely to break. So how can we reinforce it with a radius? Go back to the computer, model it, print it again, or use that leftover filament which you are so tempted to put in the rubbish bin, put it into a rotary tool and fix it. So we'll be trying all of these techniques today, and in the end, so what's going to happen is that right now the class actually started at around 3:30. So we are a bit behind time. So for the next 20 minutes, we will be having half of you trying out the different kinds of rotary tools, attachments and all that, and also the fasteners as well as everything at that zone. Whereas Sullivan and Wilfred are going to show you more, and you can also try out the polymorph 3D printing pen as well as plastic welding. So after 20 minutes, we will switch over. And during the last hour of making, this is supposed to be fast and furious prototyping. So we've got a number of cans, drink cans at the back over there. So let me just point out the stuff. So we've got a number of glass jars. We've got a number of drink cans here. So these are items that typically you will throw in the rubbish bin after you finish the food. We've also got some plywood, high density foam, acrylic sheets, plywood, and so on. And we also have 3D printed parts that are not strong because of the design, as well as these amazing things. So today, I have 4 batteries over here, and these are the batteries that are found in power banks. So we always talk about making, and we are always passionate in spreading the maker message. We always make things that sometimes people on the outside think are geeky. People on the outside think are too technical for me. I think I've got to be an engineer before I can do this. No, I don't think I can do it. I'm only a housewife. Right? But everyone can use a power bank. We know this. So today, these are the power bank circuits that are in our typical power banks. We are going to use those materials and make beautiful enclosures for power banks. We are going to build power banks today. So how does this sound? And these power bank circuits are typically available even from China online for like $2 Singapore each or so. And there's a lot of different casings available and all that as well. So even as we think of making, even as we want to share our passion about making together with our loved ones and those around us and those who attend our spaces, our creative spaces as well as our maker spaces, let's encourage making that is in a form other people can consume. If we can produce something, can others consume it? Can they use it? So I made this. If I made something, then there's an emotional value that's attached to it. So I value it, I like it because it's mine and it's mine my way. So even with these simple exercises today, so some of you may actually wish to use the drink cans and glass jars and Subaru and polymorph and make some kind of beautiful handle, try out the materials. Others may wish to make power banks. So let's get started. So for